Hi guys, welcome back. Today we're going to move on to inequalities, which are similar to equations, but instead of being just equal to, they can be less than, greater than, less than or equal to, or greater than or equal to. Let's start with the warm-up using the distributive property. Simplify -2 times the quantity x plus 7 minus 4 times the quantity 2x minus 1. Pause the video here to see how you do first. Okay, you should first distribute the -2 to this set of parentheses and then -4 to this set of parentheses. So when you distribute -2, you get -2x, and then -2 times positive 7 gives you -14. Just going to use a different color to make it a little easier to see. And now when we distribute this -4, -4 times positive 2x is -8x, and -4 times -1 is positive 4. Now you can see that you have like terms with the -2 and -8, and -2 minus 8x or -2 plus -8x, since they're both negative, give you -10x. And then you have -14 and positive 4. -14 plus 4 is -10. Okay, so in simplified form, this is -10x minus 10. All right, let's start with solving and graphing inequalities. Copy down these notes so that you have these steps when you need to look back at them. Number 1, you're going to solve just like a regular equation. Your goal is still to isolate the variable. So you graph on a number line. If it's just less than or greater than, you use an open circle and you place it on the number line, and we'll look at some examples in a few minutes. And if it's less than or equal to, this line underneath shows you that it's also equal to, or greater than or equal to, you use a closed circle on the number line. And then you draw an arrow to the left or right to represent the direction of the solution set. So let's take a look at what some of these graphs look like that are already made. So the first graph, I see that on my number line there's a circle, and it's an open circle on -9, and the arrow is pointing towards the left. So you start by picking a variable, so I'm going to use x. And I'll place it on the left side. And because it's an open circle, I know that it's either just less than or greater than -9. So because the solution is on -9, I know that x has to be less than or greater than -9. Well, everything is pointing to the left of the number line, so all numbers to the left in this direction are going to be less than, because down here we would have -10, -11, -12, and so on. So I will show a less than sign. So this graph shows that x is less than -9. Now look at number 2. So it's very similar, but the solution is on -17 this time, and we have a closed circle. So closed means that it's also equal to. So to represent the inequality, I have x is less than -17, but because it's a closed circle, we also want to make it equal to. So this solution includes the number 17. It's all numbers that are -17 and anything less than that. So -18, -19, -20, and so on. Okay, now for number, yeah, I have a 2. I meant to put number 3. For number 3, we see that the solution is on the 3. We have an open circle and now going to the right. So again, open circle means that it doesn't include the number 3. So we have x is what then 3? Well, because everything's going to the right, it's all numbers that are greater than 3, but it doesn't include 3. So examples would be 4, 5, 6, and 7, and so on. Okay, now we have a very similar one to number 2, but I see here that I have a closed circle going to the right, so that means it's also equal to, so it's x is greater than or equal to negative 17. This includes negative 17, so all answers part of my solution set would be negative 17, negative 16, negative 14, the number 0, the number 2 million, everything to the right is part of my solution set. Pause the video to try number 5 and 6, and then we'll go over them in a second. Okay, so for number 5, you should have said that x is less than, just less than because it's a open circle, less than 4. And then for number 6, you should have said that x is greater than negative 20. And again, just greater than, not equal to, because of the open circle. Okay, now let's try to solve and graph some of these on our own. Okay, looking at number 1. So x plus 5 is greater than or equal to 3. Well, to solve this, you first want to subtract 5 on both sides, just like a regular equation. Oop, pardon my line. And then you get x is, well, what's 3 minus 5? That's negative 2. And now look at the sign. We have x is greater than or equal to negative 2. So now, how do I graph this? Well, because it's equal to, I need a closed circle on the number negative 2. So I've already numbered my number line, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. So on negative 2, I need a closed circle. So you want to fill that in, showing that negative 2 is part of your solution set, and everything greater than negative 2. Okay, and you have to draw an arrow to show that it's all numbers greater, infinitely greater than negative 2. Okay, now we have negative 2 is greater than n minus 4. So I want to isolate n. So first I would add 4 to both sides. Do the same to this side. Okay, negative 2 plus 4 is 2. And I see 2 is greater than n. So I always tell the kids to write this in terms of the variable. Instead of saying 2 is greater than n, that also means n is less than 2. So I'm not changing the side. If you think about the alligator method when you were younger, you see that the 2 is still the number that's being grabbed by the alligator. I just switched it around to have the variable on the left because it's easier to graph that way. This way you don't end up making any mistakes. So n is less than 2. So because it's not equal to, I need an open circle this time. Do not fill it in on 2. And all numbers less than 2 are in this direction, again showing an arrow to show that this goes on forever and ever. So now there is one tricky rule that you have to remember in order to solve inequalities. So the rule is when you're isolating the variable and you multiply or divide by a negative to isolate the variable, you have to flip the inequality sign. So you might want to write this down. If you multiply or divide by a negative when isolating the variable, switch the direction of the inequality. So here's an example. graph the solution to negative 3x is less than negative 12. Well, we're going to divide by negative 3 on both sides, and because we're dividing by a negative 3 in our last step, we now need to change the direction of the inequality. So when you divide negative 3 on both sides, you're left with x on the left side, and instead of it being less than, now because we divided by a negative, we have to switch the sign to being greater than. And negative 12 divided by negative 3 is positive 4. So your final answer is x is greater than 4. And now if you remember to graph this, this would be an open circle on 4, and everything greater than would be towards the right. Okay, this is not to be confused with this example where you're solving positive 3x is less than negative 12. Here you're dividing by a positive 3 to isolate the variable. So even though you do negative 12 divided by 3, this negative 12 was already negative. In order to isolate the variable, you're dividing by positive 3. So in this case, you don't flip the sign, because again, this is only if you isolate it, this is only when you do it to isolate the variable. So we would be left with x is less than negative 4. Okay, hopefully you can see the difference of isolating the variable. Here we had a negative and here we did not. So let's look at this example now. Okay, just had to rearrange that. X divided by negative 3 is less than negative 1. So now here, to isolate the variable, I have to multiply by negative 3. Because x is being divided by negative 3, the inverse is to multiply both sides by negative 3. And because I'm multiplying by a negative, I have to flip the sign. So I'll multiply by negative 3 on both sides. So I have to flip the sign. And negative 1 times negative 3 is positive 3. Remember, a negative times a negative, or a negative divided by a negative, is a positive. So again, an open circle because there's no equal to sign, and everything greater than positive 3 is in this direction.